Good afternoon. I'm going to talk to you today about reasoning and algebra. And today we have got our parents' guide to algebra. So when we asked you some of the things that you wanted some support with, algebra came up, and I'm hoping to make it seem a little more simplistic and give you some clarification on how we teach it at Hanwell Fields. So algebra is just another name for, it's the part of mathematics in which letters and other general symbols are used to represent numbers and quantities in formula and equations. Now, if like me, you've got horrendous memories of what algebra was like at school, it's really important for us that we don't place those negative feelings onto our children. So algebra is something that we taught to our children and we draw quite early on so that they get used to it. Algebra is not. It's not that. It's not those horrendous equations that if you were really bright, you understood, or if you were like me, they just seemed like they were talking another language. And hopefully I can give you some examples of that. So early algebraic thinking. Algebra is about missing numbers, about finding a missing amount, about using the information that we know to work out what we don't know. And this is early algebra. You can see that we've got some information, and there's some information missing, and we use that information to find out the parts that's missing. So that is early algebraic thinking, and we can play a part in this by encouraging our children to have a go at this sort of problem and not be worried if they get it wrong. And that means they're going to be more flexible thinkers, more able to try. So 8 take away x equals 5, but we don't use the terminology X when it's early thinkers. We'd probably just put a question mark, or we might say something. We might, if we're talking about a part whole, we use our hands quite a lot to recognize that 8 is the whole, 5 is a part, and I would say mystery number is a part, and together they equal 8. And that terminology allows our children to recognize that they need to undertake a subtraction. So year 1. There are 20 counters in a box, 12 are red and the rest are yellow. So you can see there that we're scaffolding early algebraic thinking by their physical representation of the number. And here we can see the value that we have, but we can also see the missing value. 12 adds something equals 20. And there's that missing value there. And again, we've shown it in a different way, in a different representation with a part of the whole. 20 is my whole, 12 is a part, and the mystery number is a part, and we would encourage our children to think through how we're going to answer that. Here we've got the bar model. So for those of you that came along to mathematics and representation and drawing, a workshop that I did a number of years ago, we showed the importance of the bar model. And the bar model enables us to see what the whole, the value of the whole, and the representative size of the part. So 13 and the missing part. So I might sketch a bar model into a child's book, and that would help them to recognise what they're going to need to do. 20 add x equals 13. No, not at all. 13 add x equals 20, or 20 take away 13 equals x. And again, we don't use that terminology, but that is definitely developing their algebraic thinking. You'll notice down here when we're drawing our representation that actually the size is relative, it's important. So it's important for children to see that the 5 is actually smaller when we're using representations to scaffold that thinking, and that the missing element is going to be larger than that. And this helps them to see and check any misconceptions. If they end up with an answer of 25, they'll recognise that actually the 25 plus 5 is not going to equal my 30. Using algebra to solve problems. So these are the sorts of things that I might have shied away from as a child because I'd never necessarily been given the time to explore what I know. So here we can see there's 2 pears and a lemon, and there's 2 pears and an orange. That means a lemon is 7 greater than an orange. So you can see there how we've worked on that. So I'll give you a minute to have a look at that. So we'd spend some time with this sort of problem, enabling children to say, what can you see? What do you notice? So we'd expect them to notice that here we've got 2 pairs and here we've got 2 pairs. So the value of those 2 pairs is going to be equal, and the difference is going to be between the orange and the lemon. So it would be no point working out this row here or this row here because I've got one of each. And we might get children to explore this with counters. We might get them to hypothesize. What could it be? Have a go, put a number in and see what you think it might be. Again, there's also the odd and even element here. So we've got 3 values. Those 2 values together must be even. So this must be an even number as well, because 3 even numbers there. Otherwise, if that were an odd number, the answer would be odd. So it's drawing on those connections. It's continually making connections. We know this number here must be odd because I've got 2 there, and 2 times anything as a multiple of 2 is always going to be even. So that's another interesting one. And again, the same conclusion here. I've got 2 pairs and they're going to be each of the same value. So multiples of 2 are even. So the lemma must be an even value. So the use of the bar model. So it represents different equations, and we introduced that word at year 4. We talk about equations, and we don't talk about it in any great complex way. We talk about it being an equation. So can you predict? So notice we're not asking what the answer is. We're just asking, can the children recognise that 42 equals 36 add x? Can they recognise that 42 subtract x equals 36? Or that 42 subtract 36 equals x? So just playing around with what those number sentences could be using that value of x just makes it seem non-threatening and enables children to make those connections between the values they know and the missing value. Now we move up to years 5 and 6, where we're moving to more formalised algebraic thinking. So you can see we've got 3 characters there. If Jamila has X badges, how can the number of badges that Mo and Danny have be represented? So we're looking at them generalising now and making an algebraic expression. I've got twice as many badges as Mo. So here we go. Let's have a look then. So we know number of Mo's badges is X plus 6. Danny's got 2X. And we use that expression. We use that expression there to show multiply by the number of badges multiplied by 2. Twice as many badges as Mo. So Danny has got 2x, 2 times the value of Mo, she's got x. So we use that as an expression. And problem solving with algebra. So Jen is building a rectangular fence for her garden. So being able to access this is dependent upon their understanding of perimeter and knowing that if we're looking at a perimeter of a rectangle, opposite sides are going to be equal. So we're looking at the formula, a generalization that we can apply to any calculation. So here we can see that we've got 2a and 2b. And I've just noticed an error that I've made in there, which is interesting. So the perimeter is the length of the whole. That's going to be the large number here. 2a is actually going to be a larger value than 2b because the length of a is longer than b. So I've just noticed there that I've drawn my bar model incorrectly, which is always interesting. 2a plus 2b. And if a, then I only need to know the value of a and I only need to know the value of b. Making those generalizations makes the mathematics so much more simple. So it's 2a, and that circle, if ever we see that circle in any of our workbooks, it's asking the children to figure out what the operation is. So I would want children, when working out the perimeter, to know that the perimeter is 2a plus 2b. And the misconception with using algebra with perimeter is that they often think it's multiplied because area is multiplied. So we would draw attention to that. So algebra is just another name for. So I think just to leave you on this, if ever you're a bit concerned if children come home and say they've got algebra homework, it's just a name for the part of mathematics in which letters and other symbols are used, so not always X, to represent a missing number or a quantity in a formula and equation. As ever, if there are any other questions, please don't hesitate to get in touch.